is a base signal that does not require a parameter. In the case of a destroy drop, we don't need to tell the we don't need to provide the drop that was destroyed, because it is not going to exist anymore. And as we are using that event for the drop and box count, we don't need any parameter. Here we have the same for boxes. For create bullet, we have a signal bullet that, as you can remember, has a game object, a prefab game object, and vector tree as direction, and a vector tree as a position. So we have our create drop event. We also use a signal symbol for our on bullet speed toggle, and we put the name here. So now we have our signals and our events. Now we are ready to connect signals to entities with their callbacks, so then we can emit and receive those events. For example, we do that in here in drop. On our awake method, that is called when our drop is created, we go to game signal events. Oh, sorry, I forgot to explain something. These game signal events and framework signal events inherit from the singleton class that is going to make this act as a singleton. A singleton is an instance that can only exist once in our system. So if the instance does not exist when you need it, it is going to be created. If it exists, it is going to be returned. So here we are asking for that instance. It is a static field that we access. Sorry, we were here, and okay, we are here. Here we are emitting signal events. First, we need to know how do you connect. For example, here you ask for the instance and go for the particular signal event and use the connect method and provide this first parameter. As you can see here, it will tell you that the first parameter is the listener, and the second is the connection, that is our callback that requires a drop parameter. So we pass each callback for each one of the signal events we want to connect to. For example, let's look at these callbacks. Here on drop created, we grab the drop and ask for its transform that we already have in this field, and we change the parent, so we can assign a new parent to the drop, and we have our scene organized. Here we increase the drop count, and we call this method that updates the drop count display, that it is a text from the Unity UI system that we have the reference here. We have our prefix and our our count that we convert to string. Our prefix is drops count, and we have the box prefix. Um, Here we have also the name for our containers that we create when we start the application. So that is our callback for box created. For box destroyed, we only decrease our count and update the count display. And for example, the create bullet signal event, it is called by canons, and it is called directly here when we do a left click. So we have this method that we use when we use left click, and we have the event that calls this method when the bullet creation is made by canons. So when the event is fired, we receive a prefab, we receive the position and direction, and we use that prefab to instantiate a bullet. We set the position, we use a neutral rotation. And if our direction is 0, we assign a direction. We do this check because when we create a bullet using click, we use the default direction of each one of the prefab. If it is a drop, is going to travel horizontally. If it is a box, sorry, I said it wrong. Drops are going to travel vertically, and boxes are going to travel horizontally. So in that case, in that case, we pass a direction of 0. So direction is not set, and we have the default direction. Okay, what else? Where here we can see how the events are emit. In this case, the dispatcher is the same instance, but we still pass this as the instance that is created. And here the method will tell us that we need to pass a drop argument. That is this instance. And when we destroy the instance, it is important that we disconnect. I'm sorry, this is not a connection. In this case, when we get destroyed, we emit a on drop destroyed signal event, and we send our reference, but we are not going to do anything with that reference. We could use it for debugging purposes, yeah, but we are not going to do anything else. So it is going to be deleted later. Here, okay, what happens here is that we, in our bullet class, we have here we connect to two signal events. We connect to mouse click, and we connect to on bullet speed toggle, and we pass the respective callbacks. And for left click, this is a virtual function, so the subclasses are going to handle this. And on speed toggle, what we are going to do is that we are going to update speed. And when you update speed, you ask if it is raw,